Okay, now we're going to look at the application of integration. Okay, in this question, you are given a particular curve. They didn't exactly tell you what is the expression of the curve, but they tell you y is equal to fx. There are points along. You are required to find this particular value. All right, it looks complicated at first, but I'm going to break it down easy for you. All right, where can we see this component? All right, notice it's part of the curve. All right, it's bounded by the x-axis. So meaning it must be covered by the x-axis from 2 to 5. So this will be the portion. If you agree with me. Similarly, where do you think this particular area is looking at? All right, from 3 to 9, bounded by the y-axis. Notice this will be the area. So your job is to find the green area and the blue area. One quick observation. How do we find the area? Right, let me write down the value so it's easier for you to see. You can see the big rectangle minus the small rectangle will be what you are required to find. So very good. Let's go ahead and do it. So answer that is required is the big rectangle, which is 9 times 5. Subtract off the small rectangle, which is 3 times 2. Alright, quick calculation. So the required area is actually 39. Okay, this is the second application. A particular curve is given. Alright, certain points are given as well. Your first job is to find the coordinates of A and B. How do we find the coordinates of A and B? Alright, let's take a look at point A first. Alright, do you know anything about point A? Yes, it lies on the curve y is equal to x minus 1 over x squared, and you know that it's directly above C, where the x value is actually equal to 2. So in order for us to find A, just have to substitute 2 inside. Alright, so when x is equal to 2, substitute inside. And please write out the coordinates of A. In this case will be 2, 1 and 3/4. Now, how do we find the coordinates of B? Alright, looking at B. B lies on the curve as well. B also lies on the x-axis, and remember, if it lies on the x-axis, what do? Y is equal to 0. Alright, we will have to solve for 1 over x minus 1 over x squared is equal to 0. Alright, if you do some simple manipulation by multiplying throughout by x squared, I'll get an x cubed minus 1 equal to 0. This means that x cubed is equal to 1. X must be equal to 1. Now I'm able to write out my coordinates of B. Alright, x is 1, y is equal to 0. Okay, explain briefly why the area bounded, alright, is between 7 over 8 as well as 7 over 4. Okay, where do we see 7 over 8, 7 over 4? Like I said, this is an application question. It's a little bit tricky. I'm going to simplify the fraction here first, because I'm very uncomfortable with the number here. This can be written as 7 over 8, yes. This can be written as 1 and 3/4. So basically, you need to tell me that the area that you see over by the curve from 1 to 2, bounded by the x-axis, must be between these two values. Alright, where is the area? This area. Alright, some students will go and integrate and find the actual area and show that it's in between these two answers. Alright, but you do not know where these two values actually come from. So actually your job is very simple. Show me how you can get those two values instead. Alright, so I'm going to do that now. Notice, I can have a triangle over here. Alright, I can have a rectangle over here as well. Can you see that the shaded portion in red is bigger than the triangle but smaller than the rectangle? Yes, that is what we are supposed to actually do. We need to show that that shaded area is bigger than the triangle but smaller than the rectangle, and that's what I'm going to do now. So let me write the working. It's smaller than a rectangle, but it's for sure bigger than the triangle. How do we find the area of a triangle? The base is 1, the height is 1 3/4. So this will say half times base times height. How do we find the area of the rectangle? The base is 1, the height is 1 3/4. Alright, do some simple manipulation. What do you notice? The 1 on the left side becomes 7/8. The area of the rectangle becomes 1 3/4. And you have exactly what you are required to explain. Then you will ask me, teacher, what if I actually find the actual value of this whole area in red and show that it's between those two answers? Well, I won't say it's exactly wrong, but this will be a better method to show. All right? Okay, let's come to the last example for the day. All right, you are required to sketch the curve. If you cannot remember, try to make use of your Desmo app, which I asked you to download last year, to do the sketch. All right, for me, I can remember, so I'm going to draw it myself now. All right, it should look something like that. Okay, they want it from 3 to 5. So when it's actually 3, please substitute inside the calculator. You will notice you will get 5. Likewise, if it's actually 5, substitute inside, you will notice the point down here will be equal to 3. All right, now you are supposed to explain why this lies between 6 and 10. All right, let us give it a try first. Where exactly is this area? All right, it's the curve bounded by the x-axis, covered by the x-axis from 3 to 5. So this is the area we are looking at. You need to show me that this area is between 6 and 10. Again, I would not like you to integrate, but pause the video and go and see what kind of area are we looking at if you want to find the value of 6 and 10 before you come back to the video. All right, now let me check it out. Where can we find the value of 6? Because the shaded area must be bigger than 6. All right, let me draw it out. Do you agree that the shaded area is bigger than the rectangle that I just draw in green? How do we find the area in green? Likewise. All right, do you agree that the area, the shaded area in black, is also smaller than the area in pink, which you see right now, the pink rectangle? So how do we find those two areas? Let me write the steps out now. So you have the area of big rectangle, which is the one in pink. It's smaller than that one, but yet it's bigger than the area of the small, it's bigger than the area of the small rectangle, which is in green. How do we find the area of the small rectangle? All right, the base is 2, the height is 3. Similarly, how do we find the area of the big rectangle? The base is 2, the height is 5, and it fits nicely. All right, I'm going to skip the intermediate. You can write for yourself. And there you go. I have explained why again. All right, some of you will choose to do this again. So I'm just going to show you. Teacher, what if I'm going to do the integration? Which you can integrate, I know. So if I were to integrate, this is what you have, right? You get a 15 ln x, and you're supposed to substitute 5 and 1 inside. So if you put 15 ln 5 minus 15 ln 1, sorry, I just realized I made a mistake. I have written the wrong lower limit, so I'm going to change it now. So I substitute the wrong value inside. Right, it's supposed to be a 3. So please take note, the lower limit is a 3. So when I press the calculator, I will get a 7.66. All right, and you will tell me, yes, teacher, 7.66 is greater than 6. It's smaller than 10, and hence I still show it. Yes, you're not wrong to say that. All right, that is if you cannot use the method which I just showed, because we need to find exactly how to find the value of 6 and 10. All right, now you can give the other practice a try.